in this part of the course, there's going to be two types of equations that you come across quite a lot. Thermochemical equations and combustion equations. In terms of writing and balancing equations, there's nothing new here, but I thought it's probably a good time to have a little bit of a recap. With thermochemical equations, I just want to point out how they are different from what you're used to in terms of writing equations so far. So basically, with a thermochemical equation, you have your reactants that combine to give you some products. Now, obviously, where I've got these little circles or bubbles, that's where you would have the formula of the substances. So you write your chemical equation as normal. The difference is, on the end here, you'll see the molar enthalpy change. So you've got delta H equals, and then a value, which is going to be in kilojoules per mole. So that is the key difference when you're asked for a thermochemical equation. So you were just asked to include the data about how much heat energy is released or absorbed when this reaction occurs per mole of fuel or per mole of the specified substance. So that's the key thing. Ask for a thermochemical equation, make sure you've got the enthalpy change displayed on the end. Now, the other important thing to include in your thermochemical equation is the states of each of the substances. So the state should be as a subscript just below the formula of each substance. Now, you should have this in all equations, however, sometimes you can get away with it. But if you're asked for a thermochemical equation, make sure you put the states in as well as the enthalpy change. Because quite often in the questions you come across which ask for a thermochemical equation, they will give you the equation anyway. So you're not going to get credit for just rewriting what they're given. They're wanting to see the extra thing. So that's that you're pulling out the states from the information that you're given, and you're also pulling out the molar enthalpy from the information that you're given. So thermochemical equations, pretty straightforward. Just make sure you've got your states with your normally written and balanced chemical equation, and you've got the molar enthalpy in kilojoules per moles displayed on the end. Okay, next we'll just have a quick recap about writing equations for the complete combustion of carbon-based fuels. Now, the first thing that you need to make sure you write down is the formula of the fuel. Now, that formula is going to contain carbon and hydrogen and probably some oxygen as well. The next thing that you need to make sure that you put down is the state of the fuel. Now, the next part is the same regardless of what is being combusted. So for the combustion or complete combustion of all of our carbon-based fuels, the fact that it is combustion means that it is reacting with oxygen, so it's combining with O2 gas, and the products for complete combustion are always carbon dioxide gas and water. So your next step is to add that in. The next thing you're going to do is balance the number of carbons. Then you're going to balance the number of hydrogens. And lastly, you're going to balance the oxygens. Okay, let's have a look at the complete combustion of pentanol as an example. So the first thing that we need to do is write down the formula of our fuel here. So the formula of pentanol. Okay. The second thing we need to do is put down the state. So that is a liquid. Now the next thing is we add in this whole part here, because that's the same for all combustion reactions. So it's going to be combining with O2 gas, and we're going to get carbon dioxide gas plus water as our products. Alright, so the next thing we do is we balance our carbons by adding in a coefficient in the carbon dioxide. So we can see on the left hand side we have got 5 carbons, so that means that we want 5 carbons on the right hand side. Okay, and next thing to balance is our hydrogens. So if we have a look on the left, we've got 11 and 1, so we've got 12 hydrogens. So on this side we want 12 hydrogens as well. They come in lots of 2, so we're going to want 6 of those. Now lastly, we need to balance the oxygens. So if we have a look on the right hand side, we've got 5 lots of 2 oxygens here. So we've got 10 there, and then we've got 6 lots of 1 oxygen there. So another 6. So we've got 16 oxygens on the right hand side. So if we come back to the left hand side, we've got 1 here, which means that we need 15 to be added just by our oxygen. Now, because we're adding O2 molecules, we can't just add one at a time. However, because with thermochemical equations quite often we want the number of moles of fuel to be 1, we are allowed to use fractions here. So whenever you're balancing a combustion equation, when it gets to the oxygen, you just do the coefficient is a number over 2. So if we had a look at this, we want 16 oxygens in total, which we determine from the right hand side. Looking on the left hand side, we've got 1 in our fuel, so the 15 other oxygens come from the oxygen gas. We can just put 15 over 2. So by doing divided by 2, it's basically allowing us to treat this as 1 oxygen at a time, as opposed to 2 oxygens at a time in the molecule. Always just put your coefficient of oxygen over 2. If it turns out that you have an even number up the top here, like say that was 16, well, this is going to simplify. So 16 over 2 would just give you 8. So you end up with a whole number coefficient. However, if it turns out that it is an odd number that you need, you just leave it like this as a fraction. So that was just a very quick recap of 2 common types of equations that you'll be seeing in this section: thermochemical equations and combustion equations.